What's that? So you call that a square root? You know what it's really called? It's called a radical. We use it most often as a square root, but I need you to understand that it's actually called a radical. Okay? Thus, we are solving equations with radicals, as we wrote down in our lesson plans from the sideboard, right? Okay? So, here's what I want you to think about. We just finished a chapter where we talked about how to solve this, right? And how did we decide how to solve that? We said, how do we undo a squared? And we decided we square root it, right? And we said the answer was what? Oh, guys. Okay, plus or minus 3, right? Why did we have to add the plus or minus? Who put the radical in the problem? We did. So we have to think the plus and the minus, right? Do you understand that? We put the radical in the problem. Okay? So to undo a square, we square root it, right? So what if this was the problem? If we undo a square by taking the square root, how do we undo a square root? Oh my gosh. Square. And if we do it to one side, we got to do it to both, right? So what does x equal? 81. Are you positive? Good. Should we check it anyways? What's the square root of 81? Only 9. Right? Because who put the square root in the problem? It was already there, right? If it's already there, the square root of 81 is 9. Period. Yes? Okay. So what if we have a problem that looks like this? What should we do first? Well, we've got to undo the square root. How do we undo a square root? I square it. If I square one side, I have to square both sides, right? What's left on the left-hand side? So whatever was inside the square root, right? X plus 4 equals 25. So to solve this problem, I subtract 4 from both sides. X equals 21. Are you positive? But should we check it anyways? 21 plus 4. What's the square root of 25? Is it right? Good. Ooh, let's go a little harder here, right? You want a harder problem? 2 times the square root of x minus 3 equals 12. Ooh. Why do we have to divide by 2 first? Why can't we square both sides first? Can I square both sides first? Can I? Yes, but it's easier if we divide by 2 first, right? I want to isolate the radical first. When I divide both sides by 2 first, what's left on the left-hand side? Square root of x minus 3. And on the right-hand side, 6. Now that the radical's isolated, I should square both sides. Yeah? What's left on the left-hand side? X minus 3. And what's left on the right-hand side? Perfect. To solve, add 3. X equals 39. Is it right? We should check, okay? 39 minus 3. 36. What's the square root of 36? What is 6 times 2? Does 12 equal 12? Then I know for a fact that I am correct. Yes? Okay. The square root of x plus 5 equals negative 9. What should I do first? Square both sides, right? Square both sides. Because the radical's already isolated, right? On the left-hand side, what am I left with? X plus 5. And on the right-hand side? 81. And now to solve for x? Minus 5. Oh my gosh, this is so easy. 76. Is it right? Should we check? Okay. 76 plus 5. 81, square root of 81. Does 9 equal negative 9? What did I do wrong? Or maybe a better question is, did I do anything wrong? I did not do anything wrong. This is just not the answer. It is an extraneous solution. It's an extra answer that we got that's not the right answer. And in fact, what is the solution? If the only answer I get is an extraneous solution, then there's no solution. There's nothing. Think about it this way. What can I take a square root of that I'm going to get an answer that's negative? Nothing. Okay? So every time there's a negative over here, we should automatically write no solution? No. We should do the problem and then check to make sure, right? Okay? What about this one? What's that? Oh, that's a cube. Are you sure that's not just like a 3 multiplied by x? No, because it's a little baby 3 kind of up high, isn't it? Almost like an exponent out in front of the root, but it's not. It's a cube root. Guys, if we undo a square root by squaring both sides, how are we going to undo this root? Cube it? Because here's the secret. There's a number out in front of this radical, right? Is there a number out in front of this one? Yes. Right? Is there look at just this term right here. Is there a multiplier out in front of this x? Yes. What is it? But we don't write it, right? Because it's understood. Does this x have an exponent? Yes. What is it? 1. But we don't write it because it's understood, right? Is there a little baby number out in front of a square root? Yes, there is. It is a 2. But we don't write it because it's understood. It's the most commonly used one, so we don't have to write it. This is a square root. We undo it by raising it to the second power. This is a cube root. We undo it by raising it to the third power or cubing it. Does that make sense? So what's left on the left-hand side? What's left on the right-hand side? 12? Oh, see, I'm going to get that answer all day, I'm afraid. Because people think 4 and 3, oh, that's 12. So I'm really glad that you know that 4 times 3 is 12. Okay? But remember, we're raising it to the power of 3. So it's really 4 to the third power, which is 64, right? 4 times 4 times 4, right? Should we check it even though it's this easy of a problem? Okay, cube root of 64. Does 4 equal 4? Okay, then we're fine. Yeah? Okay. I think I can fit one more down here. Cube root of x plus 1 equals 2. How do I undo a cube root? Cube it. What's left on the left-hand side? X plus 1. What's left on the right-hand side? Excellent. You know what some people said? 6. Those crazy kids. What do I have left to do to solve? Subtract 1. X equals? Well, try again, please. 7. Okay. Is it right? 7 plus 1? 8. What's the cube root of 8? Does 2 equal 2? Yes? Okay. What about this one? Oops. Ooh, this one looks difficult. Yeah, it's not, is it? If we've got to isolate, do we have to isolate this first? Makes it easier, right? If I have to isolate this first, what do I have to do with this? Well, it's multiplying, so I normally divide, but it's a fraction, so how about if I multiply by its reciprocal, right? Because this becomes 2 over 2, which is 1, so haven't I gotten rid of it? So I have a cube root of 2x plus 6 equals 8, 9, 6. Are you sure it's 6? Because this is multiplying, isn't it? This isn't raising to a power like this. This is 3 times 2, 6. Yeah? Now what? Cube it. 2x plus 6 equals 216. I know we all knew it was 216. And if you didn't, you could have gotten out your own dang calculator and figured it out your own self, yes? Okay. Now how do I solve for x? Subtract 6 from both sides. 2x equals 210. Divide by 2, good. X equals 105. Is it right? Okay. 105 times 2. 210 plus 6. 216. What's the cube root of 216? 6. What's half of 6? Does 3 equal 3? Then I know I am correct. Without a shadow of a doubt, right? All right, can I try to trick you? Okay. What would you like to do first? So this is the 5th root. So how do you undo a 5th root? So earlier, you know what they said? You 5th it. That made me smile. Because I knew they knew what they were talking about. We just hadn't talked about the words yet, right? So we 5th it, or raise it to the 5th power, which is what you guys said, so good job. And on the left-hand side, I get x plus 1. And on the right-hand side, I get? So I happen to know what 3 to the 4th power is. It's 81. What's 81 times 3? 243, right? Or you could have your calculator out, figure it out yourself, yes? So all that's left to do, subtract 1. So was that really a trick? What made it trickier than the other problems we've done? Oh, 5 is a bigger number. It's a 5, right? We're good. Is this right? 242 plus 1? What's the 5th root of 243? Does 3 equal 3? Then it's right. Do you have any questions about solving equations with radicals?